This video is going to be talking about set operations and Venn diagrams. So starting out, the very first set operation we're going to mention is called the union between two different sets. Now, before I talk about union, I want to revisit what I mean by U right here. This was briefly mentioned in the last video, and this represents what's called the universal set. We think of the universal set as everything under consideration. So sometimes we may be talking about a universe that consists of the integers, a universe of the real numbers, a universe of mammals on the planet, things like that. But if it's not explicitly mentioned, then it'll be implicit in the problem. But the universe is everything under consideration. And when we talk about these set operations, we're frequently going to be using Venn diagrams, which are pictures like this. And I'll talk about what that means in just 1 second. So the first one, as I said, is what's called the union of two different sets. So I'll start with a set A and a set B. Both of them are subsets of my given universe. And the union, denoted with a U, is everything that's in A or in B. Now I'm going to write parenthetically here, or both. Right, that's said right there. But remember, or in math and logic and computer science is always inclusive unless you're told otherwise. So when I say A or B, it means A or B or both. So this is a Venn diagram for A union B. Now, you've probably seen them before, but let me just briefly mention a few things. You must draw your box. Okay, when you're drawing these Venn diagrams, you must draw your box. You must draw the box. As a matter of fact, on the midterm and the final, with problems like this, and on the grade scope, if you do not draw your box, you're going to lose a point on the problem because the box represents your universal set. Okay, and whenever you consider sets, they're always subsets of some universe. Now, once you draw your box, your universe, you have your set A, and then you have your set B. And the way we indicate we're talking about parts of a Venn diagram is we shade them. So if I want to shade in the union, you can see it's in gray right here, but if I were working this one by hand, I would shade in everything in A with this hot pink color. And then I would shade everything in B. And so the union is everything that is shaded in that pinkish color. So that's the union. It's everything in A, everything in B, or what's in both. Now, if we do that with sets given in roster notation, it's going to look something like this. So A is going to be this set, B is this set. So A union B is going to be what's in one or the other or both. Now remember, with sets, repetition doesn't matter, so we just write everything one time. So I'd write down 1, 2, 3, 4, 5, 6. And then do I pick anything up new over here? 1's already written, 3's already written, 5 is new, 7 is new, and 9 is new. And so you just write that out, and that's the union. So here is how we can do this in Python. So I have two sets A and a set B given as sets. And the two different ways you can write union are with this, what's called a method, or with this notation right here. So there's my set A, there's my set B, and I'm going to print A union B using this union method on sets. And it gives me the set 0, 2, 5, -3, -1. All right, so that's my set of the union. I can use this other notation, and I get the same thing. All right, so that's two different ways you can do union of sets in Python. The next set operation we have is what's called the intersection. And the intersection of two sets is given right here. With this notation, it's basically an upside down U. So it's like the flip of the union. And this is everything that is in A and B. So there's my little and notation from logic. So this is only the things that are in the overlap. That's what's in the intersection of A and B. Now, you can see in this picture that this is what's shaded in. Another way that you could indicate that you're talking about the union. If, for example, you have 3 sets, A, B, and C, if I want to write A intersect C, I could use blue to do everything that's in A, and I could use, say, yellow to do everything that is in C in opposite direction. And then the intersection will be things that are colored both blue and yellow. So that's another way you can draw the intersection. And there's some other examples in some later embedded videos in the book that you can watch. Now, important things to note. First of all, note that A intersect B is always going to be the same as B intersect A, okay? And if it is the case that A intersect B is empty, we call those disjoint, okay? Know this term. Know what it means for 2 sets to be disjoint. It means their intersection is empty. All right. Now, if you want to write, if you have sets in roster notation and you want to write what the intersection is, you just look and see what's in both of them. So 1 is in A, 1 is in B, so 1 is in the intersection. 2 is in A, 2 is not in B, so that's not in the intersection. 3 is in A, 3 is in B, that's in the intersection. 4 is in A, 4 is not in B, 5 is in A, 5 is in B, 6 is in A, 6 is not in B, so we're finished checking everything over here. 7 isn't going to be in A, 9's not going to be in A, so we're finished checking over here. And so this is the entire intersection. In Python, we have this intersection method, and we have this ampersand to find the intersection. So if we go through this, there's set A. Let me scroll down a touch. So we have set A, set B. There's the intersection with the method, and there's the intersection using the ampersand notation. All right, moving along. The next operation is called the set difference. Whoops, sorry. I was trying to use my pen to scroll, and it made the computer unhappy. So the set difference is basically like set subtraction. So we write it like this or like this. So when you write it like this, that means everything in A, and you're going to take out everything in B. Here it's very explicit. You have A, and you subtract out what's in B. So what this is everything that's in A and is not in B. So on the Venn diagram, it looks like a cookie with a bite taken out of it. Okay, this is A minus B, or A, the difference of A and B. It's the cookie with a bite taken out of it. So you take A and you just highlight the things that are not in B. Now, this is an important note. Okay, in contrast to union intersection, the order you write these in does matter. A minus B is not the same as B minus A. Also, if A is equal to B, A minus B is the empty set. What this is saying is A minus A gives you the empty set. Okay. So that's the only case where we have equality. In every other case, this difference is not going to be the same. All right, moving on to some examples. Here's my A, here's my B. To write A minus B, you just look at what's in A and you cross out what's in B. So 1 is in B, so I wouldn't use that. 3 is in B, so I don't use that. 5 is in B, I've checked off these. 5 is in B, so I don't use that. And then 7 and 9 are in B, but they're not in A, so I don't worry about them. So what's left is 2, 4, and 6. And then you can figure this one out on your own similarly. And then down below, we have the 2 different ways on Python you can do this calculation. Try that out on your own. And then the last set operation we have is what's called the complement. And the complement of a set is everything that is in the universe. So it's in the universal set, but not in A. So basically, you take the universe and you subtract out A. So the Venn diagram here for the complement of A, this is how it's denoted, A with a line over top of it. I would shade in everything except for A to indicate I'm talking about my entire universe, but I'm not talking about A. And as I mentioned before, the complement is just the universe subtract A. An example. So suppose that we're going to define the universe this way. So it's the digits basically from 0 to 9, the decimal digits. And here's how we define A. Here's how we define B. Then A complement, I take my universe and I write down only the things that are not in A. So 1 is in A, so I take that one out. 2 is in A, I take that out. 3 is in A, I take that out. 4, 5, and 6 are in A, so I take all of them out. So all that's left is 0 and then 7, 8, 9. And that's what A complement is. And you can try something similar. You can work that out with B complement for yourself. So those are the basic set operations we're going to be using. What gets interesting is when we have more than 2 sets. So we have multiple set operations. So for example, we could form something like this. Now parentheses rules are the same as in mathematics. So you would do A minus B first, and then C minus B, and then you would take the union of those 2 sets. So on the Venn diagram here, I'm going to use blue for A minus B. So this is A, and I've taken B out. So it's the cookie with the bite taken out of it. I'm going to use orange for C minus B. So here I have the C cookie with the B part taken out of it. And then the union would be anything that is shaded in. So the union is anything that is colored. So it's the gray part in the original color. Now, there's a really great video made by Dr. Pinzon, who is a professor at GGC, a couple videos actually, working on how to do these more than 2 set Venn diagrams. So please watch these videos. When this lecture video is over, go back in the book and watch these 2 videos. And here are some you try stuff. All right, so that's everything that I wanted to cover out of the textbook. Going to the notes now. As always, I encourage you to read through those. There's some extra examples, and then we have these extra embedded video examples for you to watch. Please do that. The notes, set 34 notes, this is just a summary of some Venn diagram stuff. So I want to briefly talk about this a little bit. As you know, a Venn diagram is just a pictorial representation of relationships between sets. So we have some that you've already seen. For example, this would be the Venn diagram for a set A. This would be the one for the complement of A. This is the Venn diagram when 2 sets are disjoint. Okay, there is no overlap because they're disjoint. This is the Venn diagram for when B is a proper subset of A. Notice that B is completely contained in A, and I have things that are in A not contained in B. Here's the Venn diagram for intersection. Here's the Venn diagram for union. So these are very important to be familiar with. And as you've seen me mention or hint at, the more sets you're considering, the more circles you need for your Venn diagram. All right, so please watch these 2 videos that go over some more Venn diagram examples. And we have these practice problems. Before I move on to doing the practice problems, I want to show you in D2L, we have 2 applets from Geogebra. Now, these are linked under the table of contents, applets, set theory. This one is called Venn diagram sets 2. So the first thing you'll need to do is, once you click the button to start these, is click this right here to make it bigger so you can actually see what's going on, okay? And here's how this works. When you click on, say, A intersect B, and let me give you some notations, some notational stuff. B, with that single quote, this is another way of writing B complement, because you know, in GeoGebra you can't put a line over top easily, and so this is just a different way that's sometimes used to indicate the complement. So for example, you know, A union B with that outside the parenthesis, this is the same thing as A union B complement. So that's what that means. But when you click on one of the boxes here, it's going to highlight the one that you're referencing. So here I clicked on A union B, and so it shaded in A union B for me. If I click on A union B complement, it shades the outside. If I click on B complement, it's going to shade everything outside of B. Make sure you turn off each one when you're done. So I'm going to turn off B complement, and then I'm going to look at A intersect B complement. We'll first look at A intersect B, which is down here. And so there's the inside. And so the complement of that is going to be everything except that overlap. So play around with those. You also have another applet that shows you three Venn diagrams. And these have some numbers in them, so you can kind of write down what they are if you wanted to in roster notation. But we have more options here, right? I could do the whole universe. I could do the empty set. I could do B. I could just do B complement. I could do C minus A, like that. I can do, this one is C intersect A intersect B complement. All right, so this is really, really good practice for you to make sure you understand what's going on when you have more than two Venn diagrams. So you could do maybe, I don't know, C intersect A minus B, right? So this is the intersection of C and A. So the intersection of C and A would be this. This is the intersection of C and A. But then if I subtract B from it, right? If I subtract B from it, that's only going to leave me this part. So that's why that's this one. All right, play around with those. They're extremely useful. And now let's look at some quick example problems. Practice problems, rather. So let me pick this one first. So here I have two sets and a universal set given in roster notation. And what I would like to do is I'm going to do B, and I'm also going to do, let's see here. Oops, sorry. Give me one moment to fix this. So I want to do B, and I think I'll also do E, okay? So A is, I'm gonna rewrite it. A is 1, 2, 3, 4, 5. B is 0, 3, and 6. And A minus B, well, that's gonna be everything in A, but I'm gonna take out what's in B, okay? So starting out, 1 is in A, 1 is not in B, so it's in the set difference. 2 is in A, 2 is not in B, so that's still in there. 3 is in A, but 3 is in B, so I'm not going to include it. 4 is in A, 4 is not in B, so it gets included. 5 is in A, 5 is not in B, that gets included, and then I'm done. Remember, you just write down everything in A that is not in B. So that's what I would subtract out. For part E, A intersect B complement. Well, I know what A is. A is just 1, 2, 3, 4, 5. I'm going to write down what B complement is. So B complement is everything that is in the universe that is not in B. So I'm going to drop out 0 because that's in B. I'm going to drop out 3 because that's in B. And I'm going to drop out 6 because that's in B. And what's left for B complement will be 1, 2, 4, 5, 7, 8, and 9. And then when I do A intersect B complement, I just see what they have in common. They have a 1, they have a 2. 3 is in A, but 3 is not in B, so I don't include it. They have a 4, they have a 5. And now I've went through everything in A, so all this other stuff in B complement can't be in A. I've already went through the elements of A. And so that's what I get. Okay. So think about that and work all the rest of the problems. And now we're going to go ahead and look at an example from drawing Venn diagrams. And I'm going to draw A. All right. So remember, the first thing you must do whenever you are doing a Venn diagram is you want to draw your universe. So there's my universe. I'll label it with a U. And I have 3 different sets. So there's A, there's B, and here is C. Okay, there's my 3 sets, A, B, and C. So I want to do A union B, and then I'm going to intersect that with C. So let me use blue for A union B. So that's just going to be everything in A or in B or in both. And then I want to intersect that with C. So here's what's in C. So then the Venn diagram that I'm looking for is going to be things that are colored blue or colored green. So let me just outline that in red. Things that are blue or green. It's this part of the Venn diagram. Okay, so when you're doing these to turn in, you can do them like this and highlight the special area. You know, you could even redraw it and just color in the part you care about. As long as you've indicated to me what you're talking about, I don't have a big preference on how you do it. You could even use little marks the way that Dr. Pinzon did in her examples on those videos. So I don't have a preference as long as I can tell what you're talking about. All right. So this is everything from set theory. This includes what's called set theory 3 and 4 on the notes, but it's all on this one last video. All right, as always, let me know if you have any questions, and I hope you have a good rest of your day.